Namaste and a very, very good evening to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at the Eclat algorithm. This is part 2 of market basket analysis. Those of you who have not seen part 1, I request you to look at market basket analysis episode 1 and then come and have a look at this particular presentation. Now, even before I show you how the Eclat algorithm works, what I'd like to do is I'd like to show you which are the most important items just to refresh our memory about what we are doing. First, let me call the library A-rules. Once I do this, the next step would be to just get a high-level perspective about which are the most popular items. To do this, I can simply run an item frequency plot function. I can use this function, item frequency plot. Please observe the first letter I is in small letters, F is in caps. Similarly, P is in caps. The rest of the letters are in small letters, just in case you are replicating the code. You have to specify the name of the data set. The name of the data set that I'm using is groceries. This particular data set comes with A-rules. Once you install this particular library and call the library A-rules, groceries should be made available to you. So I have to specify groceries. After this, I can specify top n items which are most popular. I'm specifying 20, but please feel free to use the number of how many ever items that you want to see. You can see here the top 20 items that are most popular in this particular data set. In the y-axis, you have the item frequency, which is the relative frequency that is being displayed. This is the percentage. In the x-axis, I have the different products lined up here. I've got whole milk, other vegetables, rolls or buns. You have soda and yogurt, right? It appears that whole milk is the one which is appearing in more than 25% of the transactions. When you look at other vegetables, it is very close to 20% of the transactions. Rolls and buns, again, is the third most popular item which is being sold here. You have soda followed by yogurt. On the other side, what you have is domestic eggs, brown bread, you have whipped cream, you have vegetable juice, and pipped fruit. So these are some of the items which are most popular, right? Now, when you look at the last 5 items, it constitutes roughly around 7.5% of the total number of transactions. So this gives a high level perspective about which are the items which are getting sold the most. It is not displaying the remaining items because I have requested only for the top 20 items here. Now, if you want to sort of change the color of this particular graph, there's a very easy way of doing this. And that is, you can just simply say color equals 2, right? As you can see here, color equals 2 will give you the same vertical bar chart, but this time the color has been changed to red color. I think you can use this for presentation. Another way of representing the same would be to flip this chart. And easy way of flipping this particular chart is to say horizontal equals true. When you say horizontal equals true, it comes, what R does is it sorts the various items based on the ascending order of the relative frequency, right? So as we said, domestic eggs, brown bread, whipped cream, you also have vegetable juice and pipped fruit. These are some of the important items, but as you can see right at the bottom, whole milk, other vegetables, buns, soda, yogurt. These are the most popular items which are getting sold in this particular data set. Right. Let's just now move on to Eclat algorithm. Eclat stands for equivalence class transformation. I repeat, Eclat stands for equivalence class transformation. Sometimes people also refer to this as vertical a priori. Now, there are many uses of Eclat algorithm. One of the most important benefits of using an Eclat algorithm is that it uses less memory as compared to an a priori algorithm. That's the first major benefit of Eclat algorithm. The second thing is that it requires lesser time as compared to a priori, particularly for frequent pattern generation and such things. Now, every algorithm has its own advantages and disadvantages. Now, if you ask me for the disadvantages of this particular algorithm, it is the first disadvantage I would say is that it is suitable for small data set. However, if you have millions and millions of transactions and such things, it is advisable not to use this particular algorithm, as many times your system might hang. Of course, you can sort of operationalize this on cloud or on your server. That's a different matter, but it is mainly suited for small data sets. Secondly, the second disadvantage as far as Eclat algorithm is concerned is that when the transaction ID is large, it is time consuming, right? It has to look at the product associations. It has to look at product associations among millions of items. Then it becomes a bit difficult. And that's one of the problems of Eclat algorithm. Let me just quickly run this particular algorithm. As you can see here, it's pretty simple to run this function. All that you need to do is run this function Eclat. As I told you, it stands for equivalence class transformation. You can use the Eclat function, and within this function, you have to specify a few arguments. You can call the data argument. You can specify the name of the data set. The name of the data set that I'm using is groceries. I'll have to use the parameter argument here and specify the parameters that I'm interested in. Now, I will be looking at support of 0.003, right? Now, this is not a sacrosanct number. Please feel free to play with this number. You can just increase the support or decrease the support. You can also specify the minimum length. The minimum length I would specify as 2 here. So this would run the Eclat algorithm. Now it gives a summary of what it has done. Now, what is really noteworthy is that it has created 2090 sets of rules. Very, very interesting that it is creating 2090 sets. We might want to sort of inspect which of these rules are useful, and those rules which are useful from a business perspective, we can just go ahead and propose to the management. And those rules which might not necessarily make business sense, we might want to just jettison it. So, so this is what I have. I've created the object rules. Fine. Once I create this particular object rules, wherein the output of Eclat will be stored, the next step would be to inspect the contents of this particular object, to do a brief bit of to do an introspection, to do an inspection of this particular of the output produced by this particular algorithm. What you can do is you can run the inspect command. You can sort it. You can sort the rules based on the support. So this is what our returns for output. Now, as you can see here, if I scroll up, you can see a lot of rules being displayed here, right? You can see some of the rules like yogurt and You can see some of the item sets that it has sort of captured here. Yogurt and bottled water and soda tend to sell very frequently, right? It's also displaying the corresponding percentage and the count of transactions wherein these items were purchased together, like yogurt, bottled water, and soda. Similarly, when you look at another set of items, you have other vegetables and baking powder. You can see the support and the frequency of transactions which involve these items. You can look at all the items here. You can look at soda. You can look at miscellaneous beverages. Similarly, you can look at grapes and whole milk. Now, as I scroll down, you can see the count is reducing. The count goes on reducing, right? And the corresponding percentage also reduces. For example, when it comes to soda and cake bar, the support is relatively lesser. So this is what we can do by inspecting the rules produced by Eclat. Now, one other thing that you can do is use a function which is known as rule induction. I'm going to use the function rule induction. Remember, I have stored the output of the Eclat algorithm in an object called as rules. I'll be specifying the rules here. Now, the data set that I am working on is called as groceries. I can specify the confidence here as 0.5. You can see here, the moment I execute this, it says that rule induction has detected 421 rules. Fine, I'm interested in seeing what these rules are. So let me create a new object called as rules1. Now, once I create this particular object, rules1, the next step would be to inspect what is there in rules1. Again, it throws a lot of output. Let me scroll up. This is very, very useful. You can see here what it does. It gives you a very, very important perspective about which items can lead to purchase of which other item. You can see here, it says LHS, left-hand side, and then you have RHS here. It's the set of products that you see in the LHS and RHS can be best interpreted as if-then condition, right? If you just use if-then condition, this becomes a lot easier for us to interpret. What this means is if a customer buys cereals, he can also be expected to buy whole milk. So these two products seem to go very, very well together. If a person buys cereals, there's a good chance that you can expect him to buy whole milk. I can say the same thing about specialty cheese and other vegetables. So if a person buys rice, then there's a good chance that he also ends up purchasing whole milk or other vegetables here. There are certain other important statistics that gives. It mainly provides three important statistics. One is what is called as the support. The second one is the confidence. And the third one is the lift. Now, it reports the support, confidence, and lift for each and every product set, right? Now, what is there in the LHS is popularly referred to as antecedent, and what is there in the RHS is popularly referred to as the consequent. It simply means that if a person buys root vegetables and herbs, then there's a good chance that he buys whole milk. Let's look at these three important metrics like support, confidence, and lift. In simple layman's language, I am not looking at the statistics here and the formula here. Very, very simple high-level perspective to understand support would be that support indicates how popular a product is out of all the product transactions. So you can see the support here. It is just an index of how popular an item is out of all the product transactions. Now, there's a very simple way of calculating the support. It is simply number of transactions involving cereals and whole milk. You can just simply divide this by the total number of transactions. If you recall, the total number of transactions would be 9,835 in our data set. That will be in the denominator. So that's how you can calculate the support. Now, there's another useful statistic here, which is called as the confidence. Question is, how would you interpret the confidence? Now, confidence simply indicates the likelihood of purchasing both the products A and B. Right now, A and B are generic products, but here you can just contextualize it by saying what is the likelihood of people or customers buying cereals and whole milk. What is the confidence of a customer buying specialty cheese and other vegetables? So that's what the metric confidence increases. That's what the metric confidence conveys to us. Naturally, we would be going with high confidence. Now, there's a very, very useful and a powerful metric here, which is called as lift. Now, this is very, very important. And this could be a popular interview question as well as to how you interpret lift. Now, when we speak about lift, there are three cases. One case is when the lift is less than 1. When the lift is less than 1. The second case is the lift is exactly equal to 1. And the third case is lift is greater than 1. We specifically take those products with a high lift value. Higher the lift, better it is. Specifically, if the lift value is greater than 1, it is a good sign. Now, just to give you a high-level perspective as to what lift is, let's just consider a simple scenario here. If the lift value is less than 1, what does this mean? It simply means that having cereals, I'm just looking at the first row here, having cereals on the cart does not increase the chances of occurrence of whole milk in the cart. This is if the lift is less than 1. In my case, I'm getting a lift of 2.51, which is clearly greater than 1, which means that having cereals in the cart, increases the chances of occurrence of whole milk in the cart, right? So lift value of greater than 1 is something which we take very, very seriously, right? A lift is a measure that will help store managers to decide product placements on the aisle. This is a very, very important metric. I repeat, one of the main benefits of lift, that is, lift is a measure which will help the store managers decide the product placements on the aisle. To just summarize, how can you interpret lift? Imagine that there are two customers. One is, let's just call the first customer as John, and the second customer is Matthew. Now, when we talk about John, John has not bought cereals, whereas Matthew has bought cereals, right? When we talk about John, he has not bought cereals, but when we talk about Matthew, he has bought cereals. The question is, to whom should I pitch whole milk, right? Should I go and approach John, or should I approach Matthew? Given that Matthew has bought cereals, when I look at this particular value lift, I can say that there's a 2.5 times higher chance that Matthew buys whole milk as compared to John, who has not bought whole milk. That's how you can interpret the lift values. With this, I come to the end of today's presentation. To recall what we have done, we have looked at the item frequency plot, which acts like a high-level which acts like which gives a high-level perspective about the most popular items. We have used the Eclat function. We have looked at the advantages and the disadvantages of the Eclat function. Then we moved on to inspect the rules produced by Eclat. We constructed, we used the rule induction function to look at important products and important metrics like support, confidence, and lift. With this, I come to the end of today's presentation. I thank you very much for watching my today's presentation. I request you to subscribe to my channel, The Outlier. I will see you in my next video.